Okay, come now let's move on to worksheet 4.2. So in worksheet 4.2, we will need to use the periodic table even more this time now. So let's go on first to look at question 1. They say classify the following elements as metals or non-metals. Now, how do I know which elements are metal or non-metals? Refer back to your periodic table. So in your periodic table, there is a line that you need to draw. Okay, so what is this line? I'll call it the staircase line. So it starts from here. Okay, you draw a staircase. So from vertical over here, and you draw a staircase line like this. Okay, now what's the point of drawing this staircase line? Now do take note, anything on the left hand side of this staircase line, they're all considered metals. Anything on the right hand side over here, they're all considered non-metals. Okay, so left hand sides are metals, right hand sides are non-metals. Now hydrogen is a unique case, it's considered as a non-metal. So maybe I shouldn't draw it, I should classify this as a non-metal. Okay, so it's like in the middle of nowhere. So if I want to draw a little bit more, it could be like this. Okay, so this is how your staircase line would look. Hydrogen is considered a non-metal. So based on this, okay, make sure you have drawn this. Okay, so wait for a while. Okay, so let's go back to our worksheet. So if you look at all this element over here, how do I know whether it's metal or non-metal? So you look at your periodic table. So hydrogen, non-metal, because it's on the right-hand side of the staircase line. Boron, neon. Okay, where's boron and neon? Boron is over here. Neon is over here. So you can see it's on the left-hand side of, right-hand side of the staircase line, right-hand side. So that's why it's a non-metal. Let's go back here. Okay, so let's carry on now. I think for metal, non-metals, by now it should be quite okay. So if I want to just look at C, E, and F, beryllium, calcium, and iron. So beryllium is over here, calcium is over here, iron is over here. So the three of them on the left-hand side of the staircase line, left-hand side, so they're all considered metals. Okay, quite simple here. Now, question 2, state the properties of metal and non-metal. This can be all found in the textbook. So just go in the textbook, copy and paste it in. Now, I just want to highlight in your textbook, they did say that, there's this group of elements called the metalloids. Okay. Now, in your current syllabus, we are not so focused on the metalloids itself. So generally, everything can be classified as a metal or non-metal. Don't bother yourself with the idea of metalloids. Just focus on metal or non-metal. Okay, now let's carry on. So in terms of the appearances, metals are considered shiny, non-metal are dull. Okay. Metals are generally mostly solids, except for mercury. This is actually liquid. Most non-metals are gases or volatile. Volatile means low melting point / boiling point. Okay, it will melt or evaporate or it will boil, change to gas very, very easily. Okay, so they generally are gases or very volatile liquids or solids. In terms of melting boiling point, metals are generally high, non-metals are generally low. Okay, next one, ductility and malleability. So what is ductility? Ductility is the ability of the substance to be shaped into wires. Okay, ductility is about shaping into wires. Very ductile means that you can actually pull it and stretch it for it to become like wires. Malleability means that you can hammer it. Okay, let me zoom in a little bit. So what is malleability? Malleability means that you can hammer it, flat sheet. Okay, so if it's malleable, you can hammer until it becomes very thin, very flat. So metals are ductile and malleable. That's why you can make them into wires. That's why you can make them into thin layers, thin sheets. Whereas for non-metal, if you hammer it, it's actually brittle. Means that it will break easily. It will break easily into pieces. Last one, in terms of heat and electrical conductivity, we know that metals are good conductor of heat, good conductor of electricity. Now, non-metals, they're typically poor conductor of heat and poor conductor of electricity, except for carbon in the form of graphite and diamond. Okay? Now, so do take note, all the except and stuff, don't worry too much about it. So all those words that I'm underlining are the key things you must remember. Okay? Ductility, malleability, brittle, good. All those things, a bracket is good to know. Okay? But those underlined, okay, those underlined here, here, and the stuff over there, all these are the key points that you must know. Now, next one, question 3. With the description provided, identify if the following elements are metals or non-metals. So, because you know the properties of metals, you know the properties of non-metal, if I were to describe an element for you, telling you its properties, you are actually able to classify it as metal or non-metal. So the element is dull and brittle. So which element, non-metal or metal, is dull and brittle? So non-metal is dull, non-metal is brittle. So that's why this element A here is a non-metal. An element is a solid that's ductile and malleable, high melting and boiling point. So if you look at your properties here, you realize high melting boiling point is metal, ductile and malleable, also metals. Okay, so metal. Element is a liquid, but it has good heat and electrical conductivity. So if it has good heat and electrical conductivity, you know that it will be a metal. Okay, so this one also clear-cut metal. Now, so that's this part here draws to a close to differentiate between metals versus non-metals. The next segment we're going to go into is to describe a little bit more about atoms. Okay, so question 4, what are atoms? This definition can definitely be found in the textbook. However, do take note, atoms are the smallest particles of an element that have the chemical properties of that element. Okay, so it's a very, I'll say, technical definition of an atom. Okay, so just take note of this. Has it come on an exam before? Yes, here and there, but not very often. But definitions are definitely important. Okay, question 5. What does it mean to be a monatomic element? Okay, these are the elements which exist as a monatomic element. Now, monatomic means mono atomic. Mono means one. Atomic obviously means atom. So monatomic element means it's a one atom element. So the element exists as one atom on its own. Okay, it's not combined with anything else. So that's why we say that the element exists as a single atom. It's a one atom element. So which elements exist as monatomic element? They're actually your group 0 elements. So let me scroll down here. So this group 1. Group 1 belongs to, so group 1 is actually all the elements here. So this group 1, this group 2, this group 3, this group 4, group 5. So groups belongs to each of this column over here. So group. Now, but group 0, where are they? They're over here. So I indicate the position of the noble gases by shading them. So noble gases are actually the monatomic elements. Okay, maybe I shouldn't use blue here. I should change my color, sorry. Okay, let's use red because that's the answer. So noble gases are actually your group 0 elements. Okay, they are actually your monatomic elements. Okay, so down here, all these elements over here, they are the noble gases, which means that they are also your group 0 elements. Why is it group 0 elements? Because this whole column here is known as group 0. Okay, so that's all for this worksheet.